So all of you please listen. A body of mass 0.5 kg. So you have to draw a rough diagram, otherwise you cannot understand anything. Rakshana, good evening. A body of mass 0.5 kg, let us draw a diagram. A body has mass 0.5 kg. Just draw some diagram, okay? Travels in a straight line. This body traveling along a straight line. If the diagram is not there, you cannot understand the problem, okay? A body mass 0.5 kg traveling along a line. The velocity is given by the formula. It is a tough question taken from NCERT. The velocity is a variable velocity. As the body moves, the velocities keep on changing. The velocity is given as a into. During the motion, the velocity is keep on changing. The velocity is given as a into x raised to 3 by 2, where a is 5. A is a constant 5. So v equal to 5 into x raised to 3 by 2. V equal to 5 into x raised to 3 by 2 given in the question. You can zoom if it is not visible. X is the position, the displacement mentioned in the question. X is the position of the body. So this formula meaning that as the position of the body changes, the velocity changes. X stands for the position, right? For example, initially the position x equal to 0, understood. Then after that the position will be 1 meter, then 2 meter, 3 meter, 4 meter, like that. Finally, position of the body is given as x equal to 2 meter. The mention in the question, the body is traveling from the position 0 meter to 2 meter. It is mentioned in the last sentence. Okay, clear. I hope you have understood. Saida, you join. Rakshana also join. Okay.
Yes, sir.
Rakshana, you were absent in the previous class.
Yes, sir.
But you listen. So the question says that. So I repeat the question. There is a body having mass 0.5 kg. You know, the initial position of the body will be 0 meter. The position of the body is actually denoted by x. As the body moving along a line, the position is changing. 0, then 1 meter, 2 meter, 3 meter, like that. So the position of the body changing from 0 to 2 meter mentioned in the question. As the body moving along a line, the velocity is not a fixed velocity. The velocity depends on the position. Velocity depending on the position given by the formula v equal to 5 into x raised to 3 by 2, where x is the position of the body. So all these are mentioned in the question. So the way velocity is changing, the body experience a force, an external force. That is the reason why the velocity is changing. You know that the velocity is not a fixed velocity. Because of some external force, the velocity is changing with respect to x. Some external force is the acting on the body. What is the net work done by the external force for moving the body, for displacing the body from 0 meter to 2 meter? What is the total work done by the external force to displace the body from 0 meter to 2 meter? Some external force is there. That is the reason why the velocities keep on changing. So some external force is there. What is the net work done by the external force? So work done is force into displacement, but force is if you want to use this formula, work equal to force into displacement. The problem is, if you want to use this formula, work equal to force into displacement, the force should be a fixed force. You can use this formula only if the force is a fixed force. But we have the force is not given in the question. The force is not given in the question, so this formula cannot be used. This formula cannot be used. We studied in the previous class. We studied in the previous class that the work done can be found by another way. One formula is force into displacement, but force is not given in the question, and the force should be a fixed force. Here we have no idea about the nature of the force. So we have another method for finding work. Final kinetic energy minus initial kinetic energy. We studied in the previous class. The work done is equal to the difference in kinetic energies. So final kinetic energy minus initial kinetic energy is the work done by the external force. I am going to use the work energy theorem for in this case. Kinetic energy, let me complete it, or let me explain some 3 or 4 steps. After that you can ask me doubt. Okay. Kinetic energy, final kinetic energy. The velocity, okay, the body is moving. Initially the velocity of the body, let it be vi. Finally the velocity of the body, let it be vf. Initial velocity vi, final velocity vf. So final kinetic energy will be half into m into vf square. Vf is the final velocity. Initial kinetic energy will be half mv square. Initial velocity vi. So all of you please remember, we studied in the previous class, work done equal to force into displacement. That is correct. But in the case of force into displacement, that force should be a fixed force. If the force is variable force, force into displacement cannot be used. Here I have no idea about the external force. It is not given in the question. The external force is not given in the question, so I cannot use force into displacement formula. So we have another way. Final kinetic energy minus initial kinetic energy. We have a formula. Final kinetic energy will be half mv square, vf square, minus initial kinetic energy half into mvi square. Not completed. All of you please write down till this step. All of you please write down till this step, and if you don't understand any step, please ask. If you don't understand any step, please ask. Rakshana, you okay? Aaron, Irene ഇപ്പോൾ join ചെയ്തോളൂ അല്ലേ? Okay. Everyone is clear? Okay. Mass half into m is constant. From both the terms I can take half m outside. Can I take half m outside? So vf square, final velocity square minus initial velocity square. Is that okay? I hope you have understood. Let me write the next step here. So half into m. What is m? Mass. Mass of the body is 0.5 kg. Mass of the body is 0.5 kg. But the problem is vf square, final velocity, we have no idea. But let me find out vf and vi separately. After that I will substitute here. The problem is I don't know final velocity and initial velocity. Is it given? No, final velocity is not given. Initial velocity is also not given. But we have a formula for finding velocity. Velocity equal to 5 into x raised to 3 by 2. The final velocity is obtained by substituting x equal to 2 in this formula. We have a formula for finding velocity. So the final velocity, I can use this formula. The final velocity is obtained by substituting x equal to 2 in this formula. So final velocity is equal to 5 into x raised to 3 by 2, 5 into 2 raised to 3 by 2. The final position is 2 meter. So substituting x equal to 2 here, the final velocity will be 5 into 2 raised to 3 by 2. Let me explain some 3 or 4 steps. After that you can ask me doubts. Initial velocity. Initial velocity is, again velocity, we have a formula. We have a formula for velocity. Initial velocity, substituting x equal to 0 in this formula, because initially position is 0. So the initial velocity is obtained by substituting x equal to 0 in this formula. 5 into 0 raised to 3 by 2. 0 raised to any number is 0. 0 raised to any number will be 0. Let me complete the entire solution. After that you can ask me doubt. Let me complete it. So work done is equal to, what is the formula? Half m into m. M is 0.5 kg. Vf square. Vf is 5 into 2 raised to 3 by 2. So Vf square will be 5 into 2 raised to 3 by 2 all square. I hope you have understood. Vf square will be 5 into 2 raised to 3 by 2 all square. Minus Vi square. Vi is 0. Okay. Let me complete it. After that you can ask me doubts. So half into 0.5 into squaring, 5 square will be 25. Can I square? 5 square will be 25. Here 2 raised to 3 by 2 all square will be there. Is that okay? 2 raised to 3 by 2 all square will be there. 5 square is 25. 2 raised to 3 by 2 all square is written. All of you please listen. Let me complete the entire solution. After that only you ask me doubts. 0 square is 0. 0 square 0. I don't want to write it. Half into 0.5 into 25 into, you know that 2 raised to 3 by 2 all square. In this case the power to be multiplied. 2 and 1 by 2 cancelled. Raised to, again raised to we have to multiply the powers. We will multiply the power. 3 by 2 into 2, 3 varum, 3. 2 raised to 3 varum. Power is multiplied. So you will get 50 joules. Calculation I don't want to discuss. Okay. 50 joules work is done by the external force. So all of you please note that work equal to force into displacement is true, but in that case the force should be a fixed force. In this case we have no idea whether force is fixed or variable, and also force is not given in the question. Force is not given in the question. So we use the work energy theorem. Work done equal to change in kinetic energy. We studied in the previous class. So all of you please write down. It's a very important question taken from textbook. So all of you please write down. If you have finished, please raise your hand. If you have written and under 100% clear, raise your hand. Devasri understood. Aaron understood. Ashlyn, Rakshana, Aryan, Said understood. Everyone okay? There is similar question. No need to discuss. It is taken from JEE. The next is the graphical method. Just understand the method. There is no question given in textbook. I will give you one simple example. graphical method of finding the work done. Question is not there, but theory you please understand. The graphical method of finding the work done. So far we studied two formulas. The simplest formula is force into displacement, but in that case the force should be a fixed force. But it is not necessary that the force should be a fixed force. If somebody apply a force, somebody push a chair, is the force always fixed? No. Initially we may be applying some bigger force, later we may be applying some smaller force. So if W equal to F into D is okay, but F should be fixed force, then only I will use this formula. So the another way is the most important formula is final kinetic energy minus initial kinetic energy. In this case we are not bothered about the force. In this case we are not at all bothered about the force. The force can be any kind of force, no problem. Work done equal to final minus initial kinetic energies. So two types of formula we have studied. And another way of finding work done is graphical method. The graphical method, all of you please listen. Graphical method of finding work done. All of you please listen. We are given a graph. The graph is given to us. The force displacement graph. Let me write it in words. Force displacement graph or force position graph. Suppose a body is moving, the force with respect to position. Let me draw the graph, 1 minute. Suppose this is a graph representing force versus position. Displacement is also called position. You know that suppose a body is moving like this. A body is moving like this. You know that the position is changing. As the body is moving along a line, you agree that the position is changing. For example, x equal to 0, position 1 meter, position 2 meter, position 3 meter, like that. As the body moving along a line, the position of the body keep on changing. At that time, do you believe that the force will be fixed? Not necessary. At x equal to 0, there will be some force. But when x equal to 1, the force may not be same, may be different. When x equal to 2, the applied force may be another one. So the force is not necessarily a fixed value. As the position of the body changes, the force may or may not change. So we are given a graph, position versus force. Understood? For at different positions, displacement means position, okay? At different positions like 1 meter, 2 meter, 3 meter, like that. At different positions, the force are plotted. We can see that the force are variable. Understood? At different positions, the force are plotted. Understood? So force versus displacement graph is given. I want to find the work done from the position x1. I want to find the work done from position x1 to position x2. Between the position x1 and x2, how much work is done by the external force, that I want to find out. From x1 to x2, how much work I have done. To find the work done, you just find the area under the graph. This is the graphical method. Area under the graph you have to find out. Let me write it in sentence. So work done, if the graph is given, work done is equal to the area under force position graph or force displacement graph. All of you please write down. I hope you have understood. Area to be found. The area will be equal to the work done. So all of you please write down. If you have written and understood, raise your hand. If you have written and 100% clear, raise your hand. Aaron, Rakshana, Devasri understood. Say the understood. ആഷ്ലിന് എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിക്കണം കേട്ടോ. ആഷ്ലിൻ, ആര്യൻ ഓക്കെ, ആരോൺ ഓക്കെ. So just find the area. If the question is asked, you will be given a simple diagram. Understood? Something like that, triangle or square like that. You can easily find the area. Question is not there in textbook. Remember the theory. Ashlin, complete ayo?
Yes sir.
So the work done is okay. We studied work done. We studied different methods of finding the work done. The graphical method is this. Kinetic energy we studied. Work energy theorem we studied. The next topic is potential energy. One type of energy we studied, which is kinetic energy. The kinetic energy means a moving body has certain energy. Understood? There is a mass moving with a velocity. It possesses or contains some energy. That is said to be kinetic energy. Understood? So I have already discussed that. Is there any other type of energy? Do you believe that if the body is stationary, the body does not carry any energy? Do you believe that? A body is stationary at a point. Do you believe that the body does not contain any energy? I will tell you. If the body is stationary, it is clear that there is no kinetic energy. If the body is stationary, it is not moving, then does not have any kinetic energy, but it may have another type of energy, which is said to be potential energy. What do you mean by potential energy? Have you heard about the potential energy? The definition is this. The definition of the potential energy is this. Let me explain first. Potential energy is the stored energy by virtue of the position or configuration of the body. The body left to itself releases this stored energy in the form of a kinetic energy. I will explain. For example, suppose this is the ground. All of you please listen. This is the ground. Suppose a body, I am holding a body which is at a height of h meter above the ground. There is a body, I am holding the body which is at a height of h meter above the ground. Does it contain energy? Yes. If I release the body, if I withdraw, what happens? It will fall down. It will be going down. So it will be going down means it has come kinetic energy. So initially the body does not have any kinetic energy. If I release it, it has some kinetic energy. So some energy is stored in the form of potential energy. Understood? Because of the position of the body has the potential energy. If I release it, that stored energy converted to kinetic energy. Initially I am holding, but because of the position, the body contains some energy. If I release my hand, the stored energy converted to kinetic energy. The body will be falling down. So all of you please listen. I will repeat, but let me explain one formula after that. Okay, 1 minute. Okay. Let me explain two examples. An object at a given height from the earth surface. All of you please listen. An object at a given height from the earth surface. I told you, if I release my hand, the stored energy convert to kinetic energy. And another example for potential energy is an object on a stretched spring. For example, I have a stretched spring, understood? It is stretched condition. A body is attached to one end of the spring. It is stretched spring. If I release it, what happens? It will be moving backward with some velocity. So some form of energy is stored in the body. If I release it, that stored energy converted to kinetic energy. So two types of potential energy are there in our syllabus. One is potential energy due to the position, I mean at certain height above the ground. The second one is potential energy due to the stretched spring or compressed spring. So all of you clear? The definition of potential energy is clear to you? Say the Aryan, Ashlin, Deva, Rakshana, everyone is clear. So all of you clear? So all of you please write down. All of you please write down. If you have written and understood, raise your hand. If you have written and clear, raise your hand. Everyone okay? Aaron, Rakshana, Devasri, Ashlin, Said, understood. Aryan മനസ്സിലായോ? Aryan. Okay. Next is potential energy. Next heading is potential energy of an object at a given height from the Earth's surface. I am going to derive one formula. Potential energy of an object at a given height from the Earth's surface. Look at this diagram. This is the ground, understood? Ground. The body has a mass m, which is at a height h above the ground. I am holding this. It has a potential energy because if I release it, that stored energy will be converted to kinetic energy. I want to derive the formula for potential energy. I will explain step by step. How this body achieved the potential energy? Is it automatically? No. Initially the body was on the ground. Understood? Initially that body was on ground. I have to apply some force because I want to raise it. I want to raise it above h meter above ground. Initially the body was on the ground. I have to apply some force, then the body will be going up. Every time I am applying a force, upward force, then only I can fix the body at a height h. So I have done an external force F. I have done an external force m to raise the body. So I have done some work, understood? I have done some work on this body. Whatever work or effort I have done on the body, that work is stored as the energy. Whatever work I have done on the body to raise at a height h, that effort or work is stored as the potential energy. So potential energy cannot be achieved automatically. The body cannot get potential energy automatically. Somebody has to do some work. That work is ultimately stored as the potential energy. So here initially the body will never be at a height h automatically. The body initially will be in the ground. Understood? A ball cannot be there at a height h automatically. Initially the ball will be on the ground. I have to do some work. Upward force I have to apply. Then only I can fix the body at a height h. So how much work I have done, I will tell you. Initially the body was on the ground. The weight of the body is what? The weight of the body, weight of the body is mg. You studied that, okay? You studied in the lower classes and also in the chapter laws of motion. We studied that. The weight, mass is m, the weight of the body, or downward force, the force due to the earth attraction. The force on the body due to the attraction of the force, attraction of the earth will be mg. So I have to apply the mg or slightly more than mg. I have to apply a force slightly more than mg, then only the body gradually going up. I want to slowly move the body, not accelerated motion. I want to slowly move the body upward. So what force I have to apply to raise it? I have to apply a force slightly more than, or let me say mg. I have to apply mg force upward, then the body will slowly going upward. I will clarify your doubt, but let me write some 2 or 3 steps. I have to apply slightly more than the weight of the body slowly going up. And what is the distance? What is the distance? The distance is h. I have to raise the body at this distance, height h. Am I applying a fixed force? Yes, I am applying a fixed force mg, not a variable force. So work done equal to force into displacement or distance, whatever. The work done equal to force into displacement. This f is not a variable force. Fixed force I am applying. The body slowly going up. So to raise the body, I will write all the steps. To raise the body to height h, work done is equal to force into displacement, force into distance. Displacement, force is a fixed force, so we can use this formula. Mg, the force I am applying, the displacement is h, the distance is h. mgh work I have done on the body. To increase the height h, I have done mgh work. That work is stored as the energy, potential energy. So potential energy is stored on the body. Potential energy at a height h, at a height h, above earth surface. Potential energy is normally denoted by U. The symbol is U. The effort is mgh. That effort is stored as the energy. So potential energy, please memorize mgh. M is the mass, g is the acceleration due to gravity, h is the height. So the derivation is very simple. So all of you please write down. If you don't understand any step, please ask me. If you have written and 100% clear, then only you have to raise your hand.
Sir, is there potential energy for an object in the ground?
Is there any potential energy? I mean, here we make an assumption that the potential energy at the ground equal to 0. We make an assumption like that, okay? We make an assumption that on the ground the body does not have any potential energy. We make this assumption, then only this one is correct, okay? If you have written finish, raise your hand. Said, do you have any doubt? Said?
No sir, no sir.
Understood. ആര്യന് മനസ്സിലായോ? ആര്യൻ ശ്രദ്ധിച്ചോ? ആര്യൻ Everyone okay? Finished. The derivation is very simple. Potential energy mgh. Potential energy due to height h. Okay. Everyone okay? Finished. Next is total energy of a object. Total energy. The total energy, all of you please listen. Suppose there is a body. All of you please listen. There is a body. 1 minute. Let it be a ground. What is this? This is ground. The body initially was at certain height. The body initially was at certain height. It is falling down. On the way at a particular instant. At a particular instant, the body is at a height h. The body is at a height h. And it is moving with a velocity v. It is moving with a velocity v. The initial situation, you just forget about that. Okay. There is a body. There is a body which is at a height h above ground. The body is not stationary. It has some velocity v. Understood? For example, from the top of a tower, I am throwing a ball downward. Think like that. From the top of a tower, I am throwing a ball vertically downward. So the body not only have potential energy but also have kinetic energy. If the body has velocity, definitely it has kinetic energy. So I am throwing a stone from the top of a tower. So due to the height, it has potential energy. Due to the velocity, it has kinetic energy. So the total energy possessed by the body. Total energy. Understood? TE. We can use TE. Total energy possessed by the body will be potential energy plus kinetic energy. No other kind of energy. Potential energy due to the position. Kinetic energy due to the velocity. Total energy we denote by T. Okay. In other chapter also we use only the letter T. T stands for total energy. Okay. Total energy. Total energy equal to potential energy denoted by U. Kinetic energy denoted by K. Please remember this. In the chapter gravitation, we require this formula. We study about the planets. So in that case, this formula is very important. Total energy of satellite, this formula is required. So total energy of a body is equal to potential energy plus kinetic energy. All of you please write down. If you are okay and return, raise your hand. Aaron, Devasri, Rakshana, Ashlin, Aryan, Said. Everyone is clear. Everyone is okay. Now I am going to derive one important derivation. I am going to derive one important derivation. This one is very important one. Okay. This is very important. You studied in the lower classes that the total energy is conserved. Have you studied that? Total energy is conserved. Okay. Understood. Total energy is conserved. If I am not applying any okay, total energy is conserved, that's all. So the next is I am going to derive the total mechanical energy or total energy of a freely falling body is conserved, provided air resistance is neglected. If we are neglecting the air resistance, the friction due to air, the total energy of the freely falling body is conserved. It is very important derivation. All of you please listen. All of you please listen. There is a body having mass m. There is a body having mass m. It is falling down. And this is the ground. Finally the body reaches the ground. Understood? The body is freely falling body and finally the body reaches the ground. This is the ground. The title says that during the motion the total energy remains the same. The total energy will not be reduced or it will not be increased. Whatever may be the total energy initially, the same total energy will be there for at every point. The total energy will not be changing as the body falling down. We have to prove it. We are neglecting the air resistance. So on the way, so what we are doing is we will consider three positions. Let this position be A. Let me give some name. On the way the body may be suppose on the way the body here. Let that position be B. And finally the ball reaches the ground. The position is C. B is somewhere on the way. Understood? B is some position on the way. A is the initial position, C is the final position, B is the intermediate, somewhere on the way. We have to prove that total energy at A equal to total energy at B equal to total energy at C. We have to prove it. All of it clear? Till this step you understood? We have to prove that at A, B and C the total energy are equal. All of it clear? Objective is clear?
Yes, sir.
Everyone is okay. So let us make an assumption that the total height, this total height, it is not given. Let us assume the total height. This is the total height. This total height is, let it be capital letter H, or you may use small letter h, no problem. Okay. And the intermediate on the way, the height of the body, let it be small letter h. Let us give some name. Initially the total height is h, capital letter H. On the way, when the body reaches the position B, the height is small letter h. Okay. Okay, I hope you have understood. And this distance will be, it is required actually. What about this distance? This distance will be h minus h. It is required. I will tell you the reason. The reason is clear, understood. The total height is h. The intermediate position, the height is small letter h. This distance will be h minus h. It is clear from the diagram. Okay. Ashlyn, Aryan, everyone is clear? Please remove your raise hand. Said, understood. So my objective is the total energy at A equal to total energy at B, total energy at C. The body is freely falling body. Understood? It is the freely falling body. Freely falling body. So at A, let me give a title, then you otherwise you will have a confusion. At A, potential energy is equal to mgh. At A, the position, the height is capital letter H. The potential energy of the body will be mgh. I have already derived it. But kinetic energy will be 0. Why? Because at A, the body's velocity is 0. It is freely falling body. Initially, the velocity of the body will be 0. If the velocity is 0, yes, kinetic energy is 0. So the body, initially the body has potential energy mgh, but kinetic energy is 0. So total energy, potential energy plus kinetic energy, total energy. mgh plus 0, mgh. This is the total energy at A. Understood? Total energy at A. Okay, let me give some letter like this. Total energy at A is mgh. All of it clear? Till this step you are okay? Till this step you are okay? Please respond.
Yes, sir.
Okay. All of you please write down, draw this diagram. Listen. So till this step you are okay. Now I am going to find the total energy at B. I am going to find the total energy at B. At B, what is the potential energy? Anybody? What is the potential energy at B? Please respond. Nobody is responding. What is the potential energy at B?
mg small.
Ah, yes. At B, the body's height is small at h. Look at the diagram. At B, the body is at a height of small at h. So, potential energy mgh. Here, mg small at h. All of you clear? Dakshina, Aaron, everyone is clear? Said?
Yes, sir.
Okay. Kinetic energy will be, kinetic energy at B will be, I don't know, half m into v square. Half m into v square. But the problem is, I don't know the velocity at B. Half mv square is kinetic energy, we studied already. But the problem is, I don't know the velocity at B. At a velocity at B, I don't know. That's the problem. Initially, I know velocity is 0. I will delete it. Okay. For the time being, I am writing here. Initially, I mean, if the body is at A, initially the velocity was 0 starting. At B, the body has certain velocity that I don't know. Initial velocity 0, final velocity I want to find out. From A to B, between A and B, the body has got a displacement h minus h. Between A and B, the body has got a displacement h minus h. So, is there any formula for finding V? We studied equation of kinematics. Is there any formula for finding final velocity V? Yes, I will tell you. We studied in motion in a line that we have a formula V square equal to U square plus 2AS. Do you remember this formula? V square equal to U square plus 2AS. Please respond. Do you remember this formula?
Yes.
Why I am using this formula? Because V square is required. Kinetic energy is half mv square. I want V square. V square is the square of the velocity at B. V means velocity at B. So V square I want. V square I want. We have a formula. V square equal to U square plus 2AS. U is 0. I am considering the motion between A and B. I am considering the motion between A and B. V square I want to find out. U square is 0 square. I told you the initial velocity is 0. 2AS. 2 into A. A freely falling body. The acceleration is g. 9.8. You studied that. For a falling body, the acceleration is g. 9.8. S is the distance traveled by the body between A and B. I am considering the motion A to B. S is the distance traveled by the body between A and B. Between A and B, the distance traveled by the body is h minus h. So the distance traveled by the body is h minus h. This derivation is very, very important. Don't forget it. Till this step you are okay? All of you clear? Please respond. Ashlyn, understood? Ashlyn?
Sir, can you explain how the G came?
G came. Okay, I will tell you. See, listen. In the chapter motion in a line, I don't know whether you have studied it properly or not. A falling body will have an acceleration. A falling body, the velocity will be increasing. So, a freely falling body will have an acceleration which is equal to 9.8 meter per second square. A freely falling body will have an acceleration 9.8 meter per second square. That 9.8 meter per second square is denoted by g. Understood?
Yes, sir.
So I got v square equal to, you can zoom, if it is not visible you can zoom it. V square equal to 2g into h minus h. Understood? Why I need v square? Why I need V square? Because I want kinetic energy. Half mv square is the kinetic energy. So let me write the kinetic energy at B once again. You may give the letter like this, okay? You may give the letters like this. KB, kinetic energy at B, understood. Half mv square. V square, I got it right now. 2g into h minus h. Understood. Half mv square, half mv square. Half into m into v square. V square is 2g h minus h. Everyone clear? Everyone is clear? Ashley, Said, respond.
Yes, sir.
Yes.
Okay. Rakshana understood. Rakshana.
Yes.
So 2 cancelled. Can I cancel 2? I can cancel 2. So kinetic energy at B will be 2 cancels mg into h minus h. Mg into h minus h. So I want total energy at B. I want total energy at B. It is the potential energy at B plus kinetic energy at B. Total energy at B will be potential energy plus kinetic energy. Potential energy is mgh. Kinetic energy, I got it right now. Kinetic energy mg into h minus h. Just open the bracket. You just open the bracket. Can I open? Mg taken inside the bracket. Mg is taken inside the bracket. Simple step. Mgh cancels. So total energy at B equal to mgh. Total energy at B also mgh. So at A total energy mgh, at B is somewhere on the way. The total energy at B also mgh. So total energy at A is equal to total energy at B. Now I will find the total energy at C. All of you please write down till this step. If you don't understand any step, please ask me. If you don't understand any step, please ask. If you have written, raise your hand. All of you clear? Understood? Okay? So not completed. One more step is there. 1 minute. So this one is okay. Now I am going to find the total energy at C. 1 minute. Just 1 minute. Let me delete. I want that diagram. Let me delete it. So I found the total energy at A and the total energy at B. Now I want to find the total energy at C. My objective is total energy at A equal to total energy at B equal to total energy at C. So now I am going to find the total energy at C. I want to find out the total energy at C. So at C, all of you please listen, at C. So at C is on the ground. At C, the body is on the ground. If the body is on the ground, potential energy is 0. You agree with me? At C, the potential energy is 0. You agree with me? Please respond. You agree with me?
Yes, sir.
At C, the potential energy will be 0, ground. But kinetic energy Kc has the formula half mv square. Kinetic energy is having the formula half mv square. The problem is I don't know the velocity at C. The problem is this: I don't know the velocity at C. Just before hitting the ground, the body will have a certain velocity v that I don't know. So let us consider the motion from A to C. Forget about B. B is just on the way point. Let us consider motion from A to C. I will write here. Consider the motion from A to C. B, I don't want to consider B, okay? The body is moving from A to C, right? So V square, we have a formula. V square is equal to U square plus 2AS. I have already discussed that. V square equal to U square plus 2AS. The body is moving from A and reaches C. From A, ultimately reaches C. The initial velocity is 0, correct? Initial velocity is 0. Plus 2 into A. A body is falling down. Acceleration is G. S. The body travel from A to C. The body has traveled from A to C. The displacement will be capital H. I am considering the motion from A to C. During that motion, the displacement is H. So S is capital H. We consider the motion between A and C. Okay. So the displacement is capital H. Is that okay? Please respond. Rakshana, Aryan, Aaron, Deva, all of you clear?
Yes, sir.
Ashlin മനസ്സിലായല്ലോ അല്ലേ? Ashlin clear ആയി.
Yes, sir.
So V square equal to 2GH. V square means at C. I am talking about C. So what is the kinetic energy at C then? Half mv square. What is V square at C? V square is 2GH, correct? V square is 2GH. 2 cancels. Kinetic energy at C equal to mgh. So total energy at C equal to potential energy at C plus kinetic energy at C. Total energy at C will be potential energy plus kinetic energy. Potential energy is 0 at C. Kinetic energy, I got mgh. Total energy at C equal to mgh. Understood? Everyone clear? Understood? Respond. So what I have proved? Total energy at A, mgh. Total energy at B, mgh. Total energy at C, mgh. So we derived the total energy at A equal to total energy at B equal to total energy at C. We derived it. So you can write the conclusion. Hence, the total mechanical energy of a freely falling body is conserved, means fixed, does not vary. So all of you please write down. If you have written and if you have written and 100% clear, raise your hand. ആഷ്ലിൻ്റെ ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിക്കാം കേട്ടോ. ആഷ്ലിന് ജൂലൈയിൽ എക്സാം ആണെന്ന് പറഞ്ഞു. അപ്പോൾ എപ്പോഴാണ് ക്ലാസ് വേണ്ടത്? ആദ്യത്തെ 3 ചാപ്റ്ററിൻ്റെ ക്വിക്ക് റിവിഷൻ.
സർ മൺഡേ ട്യൂസ്ഡേ വെനസ്ഡേ ഓക്കെ.
ഓക്കെ ശരി. If you have written then regarding math class I will start at 8:30. Is that okay? Now it is almost 8:10 now. Math class we can start at 8:30. Okay, Devasri, Rakshana, Aryan,
Okay, sir.
and Ashlin. Okay, 8:30.
Okay, sir.
If you have written, you may leave the meeting.